For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
I'm Bob Enyart. Today's program is our answer to those who argue that the global flood, specifically Dr. Walt Brown's Fountains of the Great Deep model of creation and the flood, that Dr. Brown's model would produce too much heat. It would boil the oceans, cook the atmosphere, and melt the crust if, in fact, it had actually happened. You know, just thinking about it, it's getting hot in here already. So today, we'll see if we can answer these critics. We provide evidence for atheists at our website, rsr.org/evidence, and a second list right there of evidence for Christians, powerful evidence in both lists to show that the global flood indeed happened. That's at rsr.org/evidence. In this instance, we'll see whether or not, in contrast, whether or not the hydroplate theory does have scientific answers to the heat critics. But regarding where did the water come from for the flood, I think all those creation scientists would agree with this. If the water for the global flood came from below the Earth's crust, then that means that their CPT model is wrong and Dr. Walt Brown's Fountains of the Great Deep hydroplate theory is correct. Where did the water come from? Walt's model describes the water for the global flood coming up from under the Earth's crust through a globe-encircling crack, which was located where today there stands the aftermath, the 40,000-mile-long mid-oceanic ridge, which then rose up and wraps around the globe like a seam on a baseball. Now, that water came up from 60 miles deep with such energy that a lot of the rock and debris that broke off the crust, it reached escape velocity and was ejected into space, beating up the moon. You know, why is the near side beat up so much worse than the far side? And filling the solar system with debris and dangerous projectiles, including meteoroids like errant bullets. So we are not surprised by many recent astronomy headlines, including what NASA considers to be Earth's oldest rock. And it was found where? It was found on the moon. An Apollo mission collected it a half century ago, but only just now in 2019, they announced that it came from the Earth. Wow. And then the European Space Agency, they landed a craft on a comet, Comet 67P, and they were shocked to see that it was made up of rounded boulders, what seems like 1 million of them, up to 10 feet in diameter, making the comet a flying rock pile. So we have a saying here on Real Science Radio that all scientists work for Walt Brown. When these headlines hit, like with so many others, we had listeners across the country, even around the world, emailing us things like, hey, Europe's space program works for Walt Brown. And NASA scientists work for Walt Brown. Yes, of course they do, because all scientists work for Dr. Brown, whether they realize it or not, because he is the author of the Fountains of the Great Deep model of the creation and the global flood, known as the hydroplate theory. So then here's the problem. If super hot water beneath the crust erupted in the fountains and ejected all that debris into space, wouldn't that overheat the atmosphere and the oceans and the crust of the Earth? To discuss that, I've asked a hydroplate theory expert to join us, like Walt Brown, who received his PhD from MIT's Heat Transfer Division in their engineering department and who worked in their heat transfer lab. Like Dr. Brown, Brian Nickel is also a mechanical engineer. He's worked for 18 years in the missile division of a U.S. aerospace firm. So, Brian, who are the critics that we're going to respond to regarding their arguments about heat?
Well, we're going to address some well-known anti-creationists like Glenn Kubin and Tony Reed,
Right.
and also some well-known scientists such as astronomer Danny Faulkner and geophysicist John Baumgartner.
Yes, and Brian, I have spoken in person, met in person with both of those latter men, the creationists. In fact, Danny Faulkner is a friend of Real Science Radio. He's, of course, with Ken Ham's Answers in Genesis. And Dr. Baumgartner was from Los Alamos National Laboratory, and then he went to Henry Morris's Institute for Creation Research.
Yes, it's difficult to keep up with so many critiques from so many sources.
Yeah.
So I'm very thankful to you, Bob, and your RSR research team for compiling the sources of all these critiques and putting them into a list. This greatly aided me in reviewing these things efficiently and determining who said what so as to examine the types of arguments out there and to determine where the disagreements lie.
Yeah, well, there are three main areas of criticism, and they regard the atmosphere, the oceans, and the crust. So heat transfer to the atmosphere, heat transfer into the oceans, and heating of the crust, some by friction, by radioactivity, and so on. We'll get into the particular arguments. And the criticism, they fall into these three areas: the atmosphere, the oceans, and the crust. Heat transfer from the hydroplate theory to the atmosphere, heat transfer into the oceans, and then the heating of the crust, some by friction, mostly by radioactivity. So what we're going to do is look at these criticisms from these atheists and creationists. I'd like us to start, Brian, with Glenn Kubin. He's an anti-creationist at the website paleo.cc, and his arguments, let's list them. He says the release of pressurized water in the eruption of the fountains of the great deep would deposit tremendous energy, and so heat, from that eruption of water on the surface of the earth. And he says the temperature of the floodwaters, they come from below the crust, and those subterranean waters being what's called supercritical, that is, supercritical water, as Walt Brown admits, they were at least 1,300 degrees Fahrenheit and hotter. So that's the beginning of Glenn Kubin's argument.
Right, and Kubin also mentions that hydroplate theory suggests that at least half of today's ocean waters were once below the crust. So with all that hot supercritical water coming up to the surface, he claims that it would have mixed with the surface waters and would have boiled the oceans.
Yeah, and he also talks about the friction from the continents sliding. This is called the compression event in Walt Brown's hydroplate theory. When the continents slid and the mountains rose up in a day, that's as the continents were sliding away from the rising mid-oceanic ridges, and they crashed. He points out that's a lot of friction, and that's going to add tremendous heat, again, to the surface of the earth.
Then there's the massive volcanic activity and the release of magma.
Yeah, and that's true, right? That did happen during the flood.
Right, so he includes that as another heat problem.
In fact, Fred Williams and I, last summer, we did a series on the eruption in Hawaii and volcanic eruptions generally, and what's called the hotspot model of islands forming. And we listed the incredible magma flows that occurred during the flood, and they were massive, so that's a pretty good point. And Glenn Kubin also talks about the hot water coming up from below the crust, and so much of it falling back down on the earth as rain. That happened for 40 days. So he's arguing, hey, that's going to add heat too to the surface of the earth.
Right. And then he also adds that the accelerated nuclear decay that Walt talks about would also add heat to levels that he believes would be lethal levels of heat and radiation.
Okay. So that's a summary of Glenn Kubin. Then we can look at Tony Reed. He has a YouTube channel called Creationism Taught Me Real Science. And what let me say that. Creationism taught me real science, and he's an anti-creationist, and he has about 7,000 subscribers, so he's sort of popular. And his heat criticisms of Walt Brown's theory that the supercritical water that came up from below the crust, that it should have transferred its heat to the atmosphere and scald the planet, saying that although air doesn't conduct heat well, steam conducts heat very well. So that's one of his arguments. And then he says that wind is usually due to a temperature differential of only a few degrees, yet the hydroplate theory has 1,000 degree water, and that differential would easily spread the heat throughout the atmosphere.
Yeah, and then Reed also claims that the water and crustal debris ejected to the upper atmosphere wouldn't have been able to lose its heat because conduction and convection was not available to it, and then claims that radiation is the weakest form of heat transfer.
Yeah, that seems to be his argument there. So if the water and debris can only radiate their heat, then it's going to fall back down to the earth very hot. So that's an interesting argument he's making. You know, and Brian, when I look at Tony Reed's YouTube channel and compare it to yours and mine, he has more subscribers, more views than we do. And so there are these anti-creationists who are going to hear his argument about no conduction, no convention up near the edges of space, and they're going to think it must be a good argument. They only have radiation as a way to lose the heat of the water that falls back down. And then also he makes an argument after the first 40 days. And some of the other critics make the same argument. After the first 40 days, when the fountains of the great deep are no longer launching debris into space, and it's no longer raining, but the waters continue to rise for another 110 days, that means that all that superheated water from below the crust, this is Tony's argument, is going directly into the oceans. None of it is going into space any longer, and it's not even going up into the atmosphere. It's just pumping all that heat right into the oceans. So those are the arguments from Tony Reed.
Yeah, well, it sure can sound very convincing.
Yeah.
Now, Danny Faulkner, who is an astronomer with Answers in Genesis, he published a back-of-the-envelope calculation where he concluded that if even a tiny fraction of the energy that Walt calculates in the hydroplate theory mixed with the surface, that it would be catastrophic as far as the heating amount, and that a large amount of kinetic energy would have transferred from the jets to the atmosphere. That's what Danny alleges.
And then he also says, and again, I'd say good friends with Danny Faulkner. When I see him, we enjoy each other's company. He's hysterical with his jokes. I just enjoy Danny Faulkner. But he also argues that when water is moving at the speeds that Walt Brown indicates, right, escape velocity is a minimum of 7 miles per second. And to get the retrograde comets and all, you need debris launching at 32 miles per second. So the water's moving fast. That would produce tremendous turbulence. And that turbulence, Danny says, would slow down at least a portion of the water jet and transfer kinetic energy to the atmosphere. And then related to that, he says the leading edge or the top of the jet of water, it transfers momentum to the atmosphere, and that would slow the leading edge. And material behind that leading edge would then do the same thing. It's a cascading effect, he says, slowing the water below it, and that this would cause the leading edge of the jet to spread horizontally. So, Brian, you use a rocket exhaust example that I think will be very helpful when we address this.
Yes, I found it to be something that I think people can visualize, and I think it will explain what Danny is visualizing, but also show how it actually moves material out away from the part of the atmosphere that contains life and would not have been an issue for hydroplate theory.
So then finally, Danny argues that the atmosphere is essentially stagnant and the fountain jets are moving incredibly quickly. And so then he calls on Bernoulli's equation, which will show a very large pressure difference that will drive air into the jet and will thermalize the kinetic energy. So that's his argument, right? The jets are going up, low pressure, the atmosphere is going to rush into those jets, and you're going to get a lot of heat that way also.
That's what Danny puts in his article. I think we can explain some things that will show that this also is not as big of an issue as one might think when they first read Danny's article.
And Brian, I wonder if the audience, people who've long listened to RSR, if they could realize already how restrained you and I are being, because normally we present something we think is wrong and we jump all over it, right? But we want to first, on this program, we want to first lay out the arguments of the critics and then begin to respond to them. So the final critic then is John Baumgartner. He's the Los Alamos creation scientist who went on to work for Henry Morris. And he criticizes the hydroplate theory's origin of radioactivity chapter. And Dr. Baumgartner writes about the extreme heat released from radioactive fission of super heavy elements. So that's one of his arguments. And then he takes Dr. Brown's own energy estimate of, so many joules of kinetic energy, on the order of 10 to the 30th joules of energy carried by what's called fast neutrons. And he points out that that energy is enough to vaporize the entire granite crust hundreds of times over. So he takes Dr. Walt Brown's estimate of energy, and this is the energy involved in producing the deuterium, which is the heavy hydrogen in today's oceans. And he says that alone would vaporize the entire granite crust hundreds of times over, and he provides some calculations to make that point.
Yeah, and then John also envisions that this waste heat from fission, which fission is when an atom breaks apart, this waste heat from the fission of super heavy elements surely must be dwarfed by the much larger amount of waste heat by a factor of 10 released in the fusion process, which is when atoms are smashed together to create new larger atoms. And that's what Dr. Brown invokes for the creation of super heavy elements.
Yeah, like uranium and thorium and so on. So Dr. Baumgartner is saying all that heat that was going to melt the crust hundreds of times over, that's dwarfed by a factor of 10, all the heat that's going to come from fusion of these radioactive elements that are really dangerous in the crust of the earth. And then John Baumgartner, and here I'll quote him verbatim, he writes that, note that Dr. Brown does not mention even once the gigantic problem of the waste heat that is implied by his processes. Why does Brown not mention this waste heat issue? One obvious reason is that there is no conceivable solution for it. And Brian, this is going to be so interesting when we get to this part of where did these dangerous radioactive elements come from in the crust of the earth, uranium and thorium and so on. Well, they came from fusion. And in Walt Brown's chapter on the origin of radioactivity, he points out the experimental evidence that shows that fusion is adiabatic, that is, it doesn't produce heat. So that is part of the response. But also, it just strikes me how Dr. Baumgartner, in his own defense of catastrophic plate tectonics, he appeals to miracles happening 3 times in the model unfolding. And then to deal with all the heat in their model, they actually argue, him and the other scientists who support his model, they say that God did a miracle and removed the heat. So
right.
I really don't understand how it is that they can make this argument against Walt's theory. If Walt did not have an answer to the heat problem, well, neither do they. And Walt could just say, well, God did a miracle. But to his credit, Walt doesn't appeal to miracles of convenience. He doesn't do that.
I believe earlier you were referring to the pot calling the kettle black.
Yeah, right. Yeah, that's true. So a few more criticisms from John Baumgartner, then we're done with this overview. He writes that scientific rigor is not a paramount issue for Walt Brown. That's obviously an ad hominem critique. And then to close out John Baumgartner's arguments, he says that the supercritical water in the chamber below the crust, that it wouldn't even remain supercritical, as Dr. Walt Brown says, but that it would turn into a plasma. That's interesting. And he says, with that much energy, on the order of 10 to the 30 joules of thermal energy, if that's all dumped into that water below the crust, then it'd be so energetic it would blow the crust right off the earth. So that's Dr. Baumgartner's arguments. And Brian, what I would love us to do before we answer in detail any of these, if we could give an overview of the hydroplate theory answers to the heat problem objections so our listeners will know where we're headed, right? We just listed all these criticisms in a summary fashion. Now, if we list about a dozen factors that help evaluate the heat consequences of Walt's theory, I think that'll be really cool.
Yeah, I think that'd be a good thing to do. So gas cools rapidly as it expands, and that's something that isn't maybe taught in grade school or anything like that, in high school and things like that. But as you get into higher learning and especially in mechanical engineering fields of heat transfer and thermodynamics, you learn about phenomena like the Joule-Thomson effect, and that's Joule, who's behind the name Joule units of energy. And also, if students are familiar with Lord Kelvin, that's Thomson and the Joule-Thomson effect. And their research showed that expansion of a gas through a nozzle, which is also called throttling, will actually cause the gas as it runs through the nozzle to cool greatly in some conditions.
Yes.
And certainly in the conditions that hydroplate theory is talking about, the effect would be a cooling effect.
Yeah, and in fact, you've pointed me to a YouTube video. We'll play a little bit of audio. This channel has 4 million views, and it's a science teacher in front of a class showing what happens when a hot gas expands. There's also the issue of directed energy we'll be talking about, and you've provided another really neat bit of experimental evidence from a Mars rocket test video and some nearby bushes, and then another photo of another rocket test firing. And Brian, they show what happens with directed energy as compared to, say, if you just have a bomb exploding.
That's right. All of these critiques and analyses, anytime you start an analysis, you have to set your problem up correctly. And if you don't, you're going to come to some wrong conclusions.
And so of our dozen or so factors that you have to consider to understand heat transfer with the global flood theory, then there's also something called the boundary conditions, right? That's important. A lot of these assumptions assume you have full mixing. Some of them actually say, and the temperature, fully averages out or full mixing. And you don't have anything like full mixing. So we're going to have to talk about boundary conditions.
Boundary conditions are very important to understand and set up in your problem when you're trying to solve these types of issues. And so that really plays a key role in determining what equations to use and to ensure that you're understanding the problem correctly.
So if you have a column of water shooting up through the Earth's atmosphere, it's the outside boundary of that column that's going to interact with the atmosphere, not the 99.999% inside the column.
it's that boundary is the only thing that can interact with the atmosphere.
Right.
Then you also have to realize what's happening at that boundary. That becomes very important to understanding this issue.
Then there's also understanding the role that supercritical water played in the flood. Dr. Brown has been the pioneer in the effort among creation scientists to recognize the significance of supercritical water in the global flood. And it's interesting to see that the scientists with AIG and ICR, those guys, they're coming along and saying, hey, supercritical water is a really important factor, and to understand how supercritical water itself behaves. That's all so important.
Another very important thing to consider is the heat sink of outer space, which is nearly infinite.
So what did you just say, the heat sink?
Right. In study of heat transfer, we refer to, it could be a plate, we could refer to things as a heat sink, somewhere where heat travels to. And so a lot of times when you're designing, say, a circuit card, well, when that circuit card is running and doing all those calculations, it gets hot and you need to put that heat somewhere. Otherwise, it's going to burn up your card. So engineers design heat sinks. Some of them could just be a large mass of, say, something really conductive like aluminum or copper to sink that heat out of the card. And in space, it also would act like a heat sink.
Awesome.
And that's where a lot of the heat was dumped during the fountains of the Great Deep, according to hydroplate theory.
And then also air itself, the atmosphere. Air is a great insulator. When we think about like thinsulate in mountaineering equipment, in mountaineering clothing, or even in our homes, the insulation we put in our homes, it's actually millions of tiny air pockets. So air itself is a great insulator. That's another...
Very important to realize and to consider. And that's one thing I have not seen are those types of considerations in some of these critiques.
Mm-hmm.
Another thing is something called the Z-pinch, which is basically, it's been witnessed in lightning strikes that heavier nuclei are created when lightning from the clouds to the ground causes basically the oxygen and nitrogen in the air to slam together and produce heavy elements. A lab in the Ukraine has discovered that this process, the Z-pinch process, is a nearly adiabatic process. And that means that it does not exchange tremendous amounts of heat with its surroundings.
So that, in other words, when these heavy elements are being made in the Earth's crust during the flood, these dangerous elements, that Z-pinch, it's making uranium, but it's not adding a lot of heat to the crust because it's a nearly adiabatic process. In fact, it's even called cold repacking by the world's leading experts. And it does seem, Brian, that a number of the critics of the hydroplate theory, they misunderstand the Z-pinch and the origin of Earth's radioactivity with all this dangerous uranium, barium, thorium, and so on. It's all dangerous elements now in the crust. It could not have been there originally in God's perfect creation. And I think a lot of the critics are unaware of cold repacking from Z-pinch.
Well, that's an important thing to be considering. Again, the devil is in the details when you're doing a critique and doing a calculation on a particular problem.
Mm-hmm.
The other factor is time. The heat was not all released simultaneously, and I think a lot of these critiques are sort of assuming that all this heat just mixed perfectly with, say, the atmosphere or the oceans all at one time, and that's just not the case.
Mm-hmm.
Another response I would have is some of these estimates. They are very tailored a lot of times to the critiquer's viewpoint. Sometimes they stop just short of defeating their own argument, where they will say, oh, well, I'm going to be generous and I'm going to only take, X percent of Walt's originally calculated energy. And then they use that in their calculation, and then lo and behold, they discover that it fries everything. Well,
Right.
That combined with the many assumptions that they're making and some of the details that they're ignoring can lead you again to some very wrong answers.
Well, Brian, I remember maybe 3 months ago when we were laying out how we were going to approach this show, I asked you, could you check Danny's calculation here, Danny Faulkner, at one point? And you did. And what interested me is that Danny took his very generous estimate to 6 digits. But if he would have gone to 7 digits, it turns out that his calculation would have defended Walt's model, not undermined it.
Right. So that was one thing that, I saw that and I wondered, well, it was interesting that the estimate was reasonable at one point, and then 1 digit over, that would have been unreasonable. I wonder what empirical thought process went into behind determining at what point do you stop.
Yeah.
It seemed like he stopped right at what was convenient.
Right. And then we only have 2 last factors that go into answering the heat criticisms. And the one is that falling cold water and ice, if you think about the water, carbon dioxide, and so on, that was launched into the upper atmosphere, as it's falling back from the edge of space back to the surface of the Earth, that will have a significant cooling effect.
That's right. And it would have been atomized small particles that were falling back. And so we'll get into it, but that'll play a big role in how much those particles could radiate.
Yeah, and in fact, after the flood, you end up with an ice age. So if God did a miracle to remove the heat, then somebody could argue, well, he removed too much heat because look how cold the Earth got. But in fact, there was something about the flood that led the globe into an ice age. So we'll talk about that. And then lastly, there's the specific heat of water. It's called the specific heat, like a watched pot never boils. It's also called heat capacity. And water's heat capacity is higher than any other common substance. That's why the oceans play this vital role in Earth's climate regulation, in our body's temperature regulation, and so on. So the specific heat of water, that's another factor. So, Brian, we've listed the heat criticisms and then an overview of the factors needed to evaluate the heat implications of the fountains of the great deep and look at specifically how Walt Brown's hydroplate theory would affect the atmosphere and the temperature of the atmosphere. I'd love to go there next. We spent about 6 months collecting the criticisms. We cataloged them, we evaluated them into 20 specific heat objections that we summarized in the beginning of this series. And they were from 4 representative critics, 2 creationists, John Baumgartner and Danny Faulkner, and 2 atheistic anti-creationists, Glenn Kubin and Tony Reed. Now, between the 4 of them and others, they've claimed that Dr. Walt Brown's Fountains of the Great Deep model of the global flood would produce too much heat, that if such events happened, they would boil the oceans, cook the atmosphere, and melt the crust. So in part 1, flood expert Brian Nickel and I listed a dozen factors that we began using in part 2 to evaluate the heat that actually would be generated and transferred to the atmosphere. On today's program, we'd like to finish the discussion of the heat and the atmosphere and then move on to the HPT's heat effect on the oceans. Dr. Brown's model describes the water for the global flood coming up from under the Earth's crust through a crack that circled the globe, which was located where today stands the aftermath, the 40,000-mile-long mid-oceanic ridge, which then, toward the end of the flood, rose up, and even today it wraps around the globe like a seam on a baseball. Now, the water that came up from 60 miles deep with such energy that much of the rock and debris that broke off the crust reached escape velocity and was ejected into space, beating up the moon, especially the near side, cratering the rocky planets and filling the solar system with dangerous projectiles, including meteoroids, like errant bullets. That water 60 miles down that came up, it was very hot. So let's welcome back Brian Nichol, a mechanical engineer who's worked for 18 years in the missile division of a U.S. aerospace firm. Welcome, Brian.
Thank you, Bob. It's nice to be back.
Well, I'm so enjoying this series. You are a professional engineer, husband, and father, and you've still found time to produce the best videos available explaining Walt Brown's hydroplate theory of the global flood. So, Brian, hey, thank you so much for that labor of love.
You're very welcome. It was really a pleasure doing it, and it's something that I feel is very important.
To continue the series, so far we've discussed some of the topics: directed energy. We talked about your hands, the photograph of your hands next to a 2,000-degree propane torch without getting burned because of the directed energy, and also because air is a great insulator. We've discussed the fluids that dramatically cool as they accelerate and expand. We've discussed supercritical water and how it behaves, and about the radiation of heat into space and into even the upper atmosphere. We've talked about how steam functions compared to the atmosphere. And even we mentioned Walt's PhD in heat transfer, of all things, from MIT. So, Brian, in the last episode, we left off talking about the Apollo astronauts and the problem with just averaging the amount of energy involved.
Well, if we just simplistically averaged the heat energy of a Saturn V rocket at launch without taking any other factors into account, we could easily conclude that Buzz Aldrin and his crew would all have been fried as well.
I guess that's true. And they were only, yards away from that tremendous amount of energy release.
Right, exactly. So hopefully these illustrations can begin to show the audience that in a small way just how important it is to see the error in assuming things like average temperature can tell you anything about whether or not something survives.
So Danny,
it simply can't.
So Danny Faulkner, as an astronomer, undoubtedly he loves the history of the Apollo missions. And that Saturn V rocket, Brian, you've showed me some video. In fact, we could play some audio of one of the clips in a moment, and photos of test firings of these rockets that really show something interesting.
These photos that you're describing, Bob, they're of test firings of the space shuttle's solid rocket boosters. They're basically a test setup where the booster is horizontal along the ground, and the rocket exhaust comes out instead of vertically, it's coming out horizontally, and the rocket motor is fixed to a huge fixture.
Yeah, a concrete building, a berm.
Right. And then basically the exhaust is allowed to just spread out however it will out into the desert. So like in one picture, we have a picture of the firing in the middle of exhausting its energy, and it's this big flame that's shooting out of there. The gases are said to be about 5,400 degrees Fahrenheit, and they're moving at 8,400 feet per second, and they produce 2,650,000 pounds of thrust.
Okay.
So a tremendous amount of energy in a small area. And yet, if you look at that picture and just 100 feet away from that picture off to the side, nothing's burning, and the dirt isn't even moving. So, yeah, it's not like everything around that rocket is completely vaporized.
Right. Nothing is charred. Certainly the soil is not vaporized. It's just sitting there. Brian, there are white spots on the ground. I think I know what they are.
Right. It's a wonderful picture because it's a great indicator of what the conditions were just 100 feet away from the rocket. And it's snow deposits from a snowfall that earlier on. And that snow is not melting. It's not steaming. That snow is sitting there not being disturbed.
Maybe less than 100 feet away. An actual real-world example that directed energy is different than the energy being spread out and averaged. Very different factor. You also then showed me a neat video of a booster rocket being tested more recently, and we have the audio for that for the audience to hear. Could you explain to us first what we see, and then we'll hear the audio?
Sure. It's a very similar test. This one was for a booster that's going to be used on a Mars mission. And when the rocket boosters ignite, certainly a large blast wave of sound does emanate from the booster. And you see that sound wave hit the bushes that are maybe hundreds of feet away. You can see
we have ignition of NASA's Space Launch System solid rocket motor powering us on our journey to Mars.
Heat from that blast wave, sound wave, as that high-speed exhaust begins pumping. Yeah.
Let's hear this thing. All right, so, Brian, when that thing fired, it was so cool to see all that vegetation, and it just jolted for a moment. But you're saying a blast wave doesn't carry heat with it. None of those trees, and they might have been closer even than you're indicating. Anybody will be able to see it. We'll embed the video. It's only a few minutes long. They didn't ignite, and they didn't vaporize.
Not the entire time. All that power and heat and energy and kinetic energy, and the best it could do was just kind of temporarily dust off these bushes that are highly flammable. Couldn't even uproot them. So you might get knocked over, but you could probably stand where those bushes are and absolutely survive that event.
Walt Brown likes to quote the adage, one good experiment is worth 1,000 expert opinions. And so Mount St. Helens, that was like an experiment in the real world. And these test firings, they're pretty good experiments. Brian, we would have had to spend millions of dollars to test this aspect of the critics of Walt Brown's hydroplate theory. Thankfully, NASA did it for free for us. Brian, we have this video pulled up here that you showed me of a science teacher holding his hand above a steam pressure cooker.
Ah, right.
Yeah. He's got this heavy insulated cooking glove on his hand. And then he asks his students if he should take the glove off. Let's play a little bit of that audio.
Okay, you want to see that more dramatically? Watch this. Here's some steam here, huh? Would I dare to take this glove away? Yeah, easy. Easy sitting there, no problem. Hot or cold? Begin with a C. It's cool, relatively cool. HC. I'm not going to put it way down at the nozzle. It turns out that that which you are seeing here, gang, is not steam. That which you can't see, that's the steam. But what does that steam do? Begin with the X. Expand. And when it expands, what's it do? Begin with another C. Cool. And there's your evidence of it right there. Isn't that remarkable?
That channel has 4 million views, so it's a
Powerful demonstration.
Yeah, and a popular science channel. Now, as we're giving this defense against the critics who say that the atmosphere would overheat from Walt Brown's hydroplate theory, let's try to include a last few particulars. Tony Reed argued that as the fountains are going up high into the atmosphere to the exosphere, they're approaching space. Walt Brown points out that they will radiate whatever heat they have in them to the infinite heat sink of empty space. And then some of that will fall back down, and it's not going to fall back down as superheated fluids. It's going to be chilled. But what Tony Reed argues is that when you get up into space, there's no conduction and there's no convection. He says there's only radiation. So I wanted to ask you about that argument. Would the fountains, whatever heat they had in them, as they get to the upper atmosphere, would they not cool down because there's no conduction or convection?
No. Remember, these particles, as they have entrained up into space, anything that didn't have enough speed to escape Earth's gravitational pull is atomized in little particles exposed to the vacuum of space. And so it will absolutely radiate its heat, and it will cool off from whatever temperature increase it experienced through any thermalization of the kinetic energy.
Yeah, and it's true that there's no convection and no conduction because the atmosphere is rarefied. There are so few molecules per cubic volume of atmosphere, but he acts as though radiation is a minor effect, that it's not really going to help remove the heat, any remaining heat. That argument seems completely false on its face.
Right. He makes a statement that radiation is the weakest form of heat transfer, and I don't read that anywhere. I've never heard of that ever before in any of my heat transfer classes or thermodynamics classes. I'd love to know where he thinks he's getting that information from. But
now, it seems to me that if an astronaut stepped out of the space station, he'd be in big trouble if he didn't have a spacesuit on.
Right, and the problem would be is that his body would tend to radiate heat so fast that he wouldn't be able to stay warm. If you look on design of spacesuits, the problems that are encountered are trying to keep the human being alive. You certainly have cosmic rays and whatnot that are adding heat, but you have a tremendous amount of heat that is radiating from the human being themselves, and the challenge is keeping them warm and then regulating their heat within the suit. But I was able to listen to a talk by a guy who worked on the Apollo spacesuits, and he went through all the life support systems of those spacesuits, and it was very fascinating. But managing heat and keeping the astronaut alive via heat management was a critical issue for them.
Brian, what would happen physically? It's pretty cool that you got to hear directly from one of those engineers. We think about the launch and all the rockets, but the spacesuit itself is astounding technology. But what would happen to an astronaut if he did step out? How would he die? What would happen to his body if he didn't have that spacesuit on?
Well, it's kind of a weird set of circumstances that aren't very intuitive to us here down at the surface, but because the pressure is non-existent, your blood would instantly start to boil, yet it would also basically be freezing at the same time. So it wouldn't be a comfortable experience, that's for sure.
So obviously we're thankful for technology. I got to interview one of the astronauts who walked on the moon, Commander Alan Bean, and other NASA engineers and scientists are friends of Real Science Radio. And one astronaut is a friend of and supporter of Walt Brown and his hydroplate theory.
Yeah.
I do enjoy thinking of the scientists from the various disciplines who support Walt Brown's Fountains of the Great Deep model, including not only an astronaut, but those in astronautics, geologists, chemists, nuclear engineering, hydraulics and electromechanics professionals, geophysicists. And in fact, if there are listeners who are scientists or engineers who would like to indicate their support for the hydroplate theory, please email me at bob@rsr.org. Brian, how about when Danny Faulkner, again, the creationist astronomer with Ken Ham's Answers in Genesis, when he talks about the turbulence that would be produced as the fountains are coming up with such speed, velocity 7 miles per second up to 32 miles per second, he talks about the turbulence that would be produced by the leading edge of the fountains, and then he sees a chain reaction effect, a cascading effect, where then the fountains are going to spread out horizontally.
Right. He imagines that somehow that is going to cause mixing throughout the entire atmosphere in some meaningful way. I think the problem is that just like with my hands over that burner, and as those gases expanded out from that, they already have momentum built up as they pass out of the nozzle. And they can't just change momentum and go sideways. They can only expand at a certain rate, but their momentum is carrying them too fast for that expansion to be significant down near the nozzle. If you think of the rocket booster tests, the same thing is happening. The expansion of that gas, even though it's expanding rapidly, by the time it leaves the back end of the booster, it is traveling at 8,500 feet per second. So even though the gas is expanding sideways, it's not expanding sideways as fast as it's moving in the direction that it's pointed out the nozzle. So for the fountains, that's the same situation where the momentum after that fluid has expanded and accelerated for 60 miles up the crack. By the time it enters into the atmosphere level where all life is, it has tremendous velocity, 7 miles per second, 32 miles per second. Well, guess what? The atmosphere itself, like 80% of the mass of the atmosphere of our air on Earth is only 7 miles thick. And so
wait, let me make sure I understand that. You're saying pretty much where commercial jets fly, you're saying in the bottom 7 miles of the atmosphere, that's where 80% of the atmosphere is. So if the fountains are erupting, and I realize the velocity is changing from when they start down 60 miles below to when they reach the surface to when they exit the exosphere, but let's say they're moving at 10 miles per second. So you're saying in 1 second, the fountains are through 80% of the atmosphere in 1 second.
That's exactly right. There's no time for that expansion sideways to occur in a meaningful way to where it would interact with the atmosphere.
Wow. Yeah, because each of those particles would have to then go sideways, and they're not.
Right. We talked about where a simple free body diagram of the speeds and the sideways expansion shows that it just simply cannot expand in the way that Danny is imagining.
When people see this diagram, a free body diagram on our website, rsr.org, I think it'll be much easier for them to see what you're talking about. Now, when Walt Brown was the director of the Binet Laboratories, if you recall that, for the Pentagon, that's a major research arm of the U.S. military, development and engineering of really weapon systems. And Walt, if I recall the numbers, he had about 100 scientists, maybe it was 30 PhDs. In fact, he said it was quite a challenge trying to manage 30 PhDs along with all the other scientists. And he's the director of the whole thing. And I never asked Walt what he worked on during that time. I'm sure at the time it was classified, but it would be an understatement to say that Walt Brown has a familiarity with weapon systems, and this is an aspect of that whole field of engineering.
Yeah, this is all very basic stuff, at least when compared to these fields of engineering. I mean, you learn this at least by your second year of engineering school.
Now the oceans, to the boiling of the oceans. Brian, we've responded to Walt's heat critics regarding their supposed scalding temperatures of the fountains and the cooking of the atmosphere. So what's left are the claims that the hydroplate theory events would boil the oceans and melt the crust. So the oceans?
Yes, the oceans. Many will say that the oceans would boil after the fountains stopped launching water and debris through the atmosphere. They say that the oceans would boil or scald or vaporize. Tony Reed is one of the most known, I guess, at least on YouTube, and I believe we even have a clip of some of what he says about that.
Yeah, and he says maybe they wouldn't boil, but certainly it would kill all of the life, marine life in the oceans. So let's hear that.
Regardless of this, Brown specifically points out that as the oceans later filled due to rain, the fountains of the deep continued to expel water even after the water level had risen to the point to where the fountains no longer erupted into the atmosphere. This means that the fountains were now ejecting superheated water directly into the ocean and heating it up. Whether or not this would be enough to make the oceans boil is debatable, but the unavoidable conclusion is that it would significantly change the temperature and the depths of the world's oceans. Since nearly all marine organisms have specific tolerances for temperature and depth, these significant changes in temperature and depth would be fatal, and the oceans should have been nearly devoid of any plant or animal life. Hydroplate theory does not take this into account.
So a month ago, Brian, I talked to Walt Brown about this specific criticism, and he pointed out that people generally, of course, they don't understand supercritical fluids. It's not something you learn about, we hear about in our normal education. So Walt says they tend to see heat problems where there are no heat problems, even where there's very little heat. And so, as Tony Reed was talking about, during the flood from day 41 to day 150, the fountains are no longer launching debris into space. But, as Genesis tells us, the waters continued to rise during that entire time for another 110 days after the torrential rains stopped. So how about that? The temperature below the crust, it was 60 miles down, right? Now I don't think it is any longer at this point in the flood. So it's still going to be hot way down there. And is it going to cook the oceans?
So after the fountain stopped and had ejected all that material, which had been eroded away from the bottom of the plate, about half of that original 60-mile thickness was now gone. And so the plates were only about 30 miles thick.
Okay. So that means the water will get to the surface in half the original distance.
That is correct. However, some of the mechanisms that were producing the acceleration and the heat being added to the waters down below the plates, those had stopped. So the nuclear events that were happening due to the plates fluttering, that had stopped because the plates were no longer fluttering. They were now just compressing down against the water and pushing it up.
Now, the audience might not be familiar with the concept of the fluttering crust. We shouldn't get into it in detail. We talk about it in other hydroplate theory broadcasts. Of course, it's in your videos in Walt Brown's book in the beginning. But as the water is coming out from under the crust, they're hydroplates. They're on top of the supercritical water, so they are undulating. They are fluttering. They're moving because the waters below them are being evacuated.
Right. It is very important to understand when these mechanisms, when they're happening, but also when they stop happening according to the hydroplate theory.
Mm-hmm.
So the important thing to realize after the 40 days has occurred and in this between time between day 40 and day 150 is that the same effects are still happening at the base of the crack down 30 miles now. Whatever temperature the water was at that point, even if it was still 1,300 degrees Fahrenheit, the same expansion is happening. The same Joule-Thomson effect of expansion and cooling is happening to that fluid as it expands for 30 miles as it rises up. And so the same temperature drop is occurring. Another relationship that speaks to this is the Clausius-Clapeyron relationship. And this relationship is a partial derivative.
That's an engineering term, right? Clausius-Clapeyron?
It's the names of the authors who came up with the relation.
Mm-hmm.
This is used all over in thermodynamics textbooks, and it is the relation that is used to plot the slope of the phase line for a temperature-pressure diagram.
Okay. So in other words, when the water is coming up in the fountains of the great deep, there are principles in physics, in fact, a relation that you can apply to investigate whether the temperature is going to be the same when it's reaching the surface of the Earth as it is 30 miles below.
Yeah, this relation, the main gist of it is that the small change in pressure divided by the small change in temperature is equal to a constant on the other side of the equation. And so since it's constant, we have a ratio where a change in pressure is going to result in a change in temperature. So if pressure drops, which is what is happening here, we have high pressure water underneath the plate, and now that pressure drops, then by definition, the temperature has to drop.
So actually addressing the temperature of the oceans is relatively easy once we've discussed the atmosphere, because one of the main points was that the fountains are not 1,300 degrees when they reach the surface of the Earth. And when you realize that that's the core of the argument, when Tony Reed says superheated water was being ejected only into the oceans, he's ignoring all these aspects of basic physics.
Yeah, he has no idea that the water was superheated by the time it reached the atmosphere or surface levels. So to say that superheated water was ejected into the oceans, it's nonsense. And again, all of these things still are assuming similar calculations that we discussed, like with the atmosphere. Well, they'll take a percentage and then they'll say the ocean would be boiled away or whatever. Well, that's, again, assuming perfect mixing, whatever the temperature is. You're assuming perfect mixing on a global scale,
Right.
and yet not offering a mechanism
Right.
that gives us a path to critique that assumed perfect mixing.
So then we've basically answered the claim that the oceans would boil or almost boil and all marine life would die because of how hot the oceans would become. Maybe we could address the frozen mammoths. Also, generally, the recognition that the water that went up into the upper atmosphere that fell back down onto the earth, so a lot of that would come down as very cold water, even ice, and frozen carbon dioxide ice coming back down from virtually the edge of space. And that does bring up the topic. Walt has an entire chapter on the frozen mammoths, and it helps us realize that after the flood, it wasn't overheating. There was an ice age that was coming on the earth, an ice age, and that seems to be the bigger temperature factor.
So in the very early stages of the flood, as water was being launched up high into the atmosphere and most of it beyond the atmosphere, some of that water was frozen to very cold, hundreds of degrees below zero. And that became, of course, super cold hail that then rained down in places. Depending on which side of the earth you were on, you might have experienced heavy torrential rain. But in some spots, when conditions were just right, massive hail dumps occurred. And the mammoths that are frozen in the tundra of Siberia and Alaska are the remains of mammoths that hydroplate theory proposes were buried in this super cold ice and frozen at the early stages of the flood.
Our dear friend Michael Ord, he's written a book about the mammoths, and a listener emailed and said, Bob, why doesn't Walt Brown take Michael Ord's theory on the mammoths seriously? And I thought, take it seriously. At the end of Walt's chapter, he has this amazing chart. And in fact, I have a hope that Real Science Radio could put all of those charts on the internet so that they become interactive and dynamic, so that Michael Ord himself could judge his own theory based on how it handles all these rows of evidence. And in fact, Walt Brown suggests if you think there's other evidence that a theory needs to address, just add some rows and grade the hydroplate theory and Michael Ord's theory. So after the global flood, there was an ice age. And when I hear the CPT, catastrophic plate tectonics scientists, saying that, yes, the crust of the earth would have melted based on their model, but God did a miracle and he removed the heat. I think, well, wait a minute. First of all, you can't use that crutch for your scientific model. God intervened and did miracles in the Bible, but you can't just assert a miracle wherever your math doesn't work. It's just wrong to do that. And not only that, if they were right, if God did a miracle to remove the heat from plate tectonics, their theory, well, then he would have removed just the right amount of heat. He wouldn't have removed too much heat and left the earth with a burgeoning ice age. In fact, the relevant temperature factors after the flood was that the surface of the earth was too cold. That was the relevant factor, and that does bring us to the frozen mammoths.
And Walt has an amazing prediction, number 25 in his book. The prediction is that directly beneath the frozen mammoths, there should be no marine fossils. There also shouldn't be any stratified layers or coal or oil or limestone directly beneath any frozen mammoth.
Wow. This is an incredible prediction, a science prediction, and predictions are the hard currency of science. And so Walt is saying that wherever you find these undisturbed frozen mammoth carcasses, if you dig down, drill down, mine beneath them, you're not going to find, what's that list of, what does he predict that will not be found, Brian?
Because they were killed right at the beginning of the flood, pretty much where they stood, they shouldn't have any marine fossils underneath them. There shouldn't be any stratified layers that are flood layers underneath them. They would have pretty much been frozen to the ground, and there shouldn't be any coal or oil or limestone underneath.
Wow, this is a huge prediction because when you think of the scope, the geographic scope on the globe, many of these frozen mammoth carcasses have been found through an area of about 1 million square miles across most of Alaska and northern Russia, and this is both inside and outside of the Arctic Circle at scores of sites. So that's how you do science. You know, Michael Ord disagrees in Answers in Genesis and CMI. They sell Michael Ord's Ice Age book. But Walt Brown comes out not only with the hydroplate theory of how the mammoths were frozen, but with this powerful prediction. There's actually a little bit of inside baseball to this because a geologist who strongly opposes Walt's hydroplate theory, he wrote a paper to say that he's falsified Walt's prediction because indeed there are sedimentary layers beneath one of the mammoth sites. And so thankfully, Walt Brown got wind of it, and the map that this geologist was using to disprove Walt, the map was misread by the geologist. And so that geologist withdrew his own paper because it was simply wrong. And so there's been one challenge, although it didn't make it to publication. But I have no doubt that Walt Brown's prediction, many of them have been confirmed, and extraordinary predictions. And we list them on our website, rsr.org/predictions. But this prediction, I think, is going to stand, Brian.
Yeah, I don't think there's any reason to believe that you should see any of those things there. And so far, his predictions are coming to be seen as reality every day. Pretty fun times to live in.
Yes. Also, when you have expeditions and the sled dogs start gnawing at the flesh of a mammoth and start eating the mammoth because his flesh is still fresh, that's an animal that lived during the flood. It was killed during Noah's flood. Some of those were crushed vertically, and they died of suffocation. And they froze almost instantly because inside of their digestive tract, there were no temperate flowers, as been reported, but there were seeds of temperate plants. And so a mammoth is so large, it would decompose of its own internal heat, even if you buried it in the middle of a glacier. But that's why Walt says we know that the temperature of the ice they were encased in was about 170 degrees Fahrenheit below zero.
Yeah, it would have needed to be at those temperatures for the cell walls of the skin to be retained and not to be broken due to slow freezing, where liquid water would have had time to develop in the cell as it putrefies. And also the fact that sled dogs, those expeditions, by the way, were completely dependent upon for travel, were able to eat meat and not get sick, because a dog will get sick by eating completely putrid meat.
Sure, right.
And yet this meat was not putrid.
Yeah.
It was at least enough to where a dog didn't die from it.
So Michael Ord and his frozen mammoths theory, Walt fully evaluates Michael's theory in his frozen mammoth chapter. You see the two theories next to one another with an amazing, basically an engineering chart, looking at all of the observations, all of the data, and seeing which theory explains which observations. And wow, does the hydroplate theory come off really well. And Michael Ord's welcome to just read regrade that chart. He could do it himself.
Yeah, anybody can. I mean, that's what Walt does at the end of every chapter is he uses a very well-established procedure for analyzing a lot of complex data and determining which theory is the best one to go with. We used it all the time when doing failure analysis on missiles and stuff, where you have a very complex system and it could have failed 20 different ways. How do you know which way to go spend your money on? Well, Walt uses that exact failure analysis technique in the back of every chapter.
Yeah, it's so encouraging. And so then also, Michael Lord, not only with his frozen mammoth model, but then with his understanding of the Ice Age, along with, I keep picking on Ken Ham, but CMI and ICR, because they reject the hydroplate theory, they don't believe the fountains of the Great Deep were water. They go along with the catastrophic plate tectonics theory, and so they think the fountains were magma. And that I have a hard time getting past that, Brian. That just really throws me for a loop. They teach that the fountains of the Great Deep, for Noah's flood, that it was magma, was lava. And I just think that is so unbiblical and bizarre. But aside from...
Yeah, it also has really a lot of scientific issues. I think they're really missing out on a tremendous foundation that Walt has laid in hydroplate theory.
Yes. We're not only responding to critics here, we're teaching basic science, and that's so interesting and so valuable. John Baumgartner and other critics claim the hydroplate theory events would melt the Earth's crust. Now, of course, Dr. Baumgartner's own theory, called catastrophic plate tectonics, promoted by the larger creation groups, his theory makes use of something called accelerated radioactive decay, which they admit by their own model, they admit it would melt the Earth. So you may wonder, then, why are they criticizing Dr. Walt Brown's model for the very same problem that their own model has? Well, we wonder that too. Jesus said, don't criticize your neighbor if you have the same problem, right? Or if you have an even greater problem. Well, their criticism, unintentionally, it highlights the hydroplate theory factors that actually remove the heat generated by flood events. In Walt Brown's model, the heat does work. In their model, all it can do is melt the Earth. That's a key difference. The hydroplate theory shows that the heat was put to work, being turned into kinetic energy, launching the fountains of the Great Deep, and being put to work in the fusion of heavy elements. For it was during the global flood that today's dangerous radioactive elements were formed, like thorium and uranium. With catastrophic plate tectonics, their heat can't launch the fountains because they don't believe that the flood fountains were made of water in the first place. AIG, ICR, CMI, they think that the fountains were magma, which shocks me, but they do, and their model adds very little water during the flood. Instead, they have tsunamis slosh the water that already existed on the surface onto the continents. And they don't believe that the fountains launched the debris that beat up the moon, especially the near side, and that formed the dangerous objects flying around the solar system, like meteorites and comets. The hydroplate theory presents the big picture of how the heat generated in that global judgment was put to work, launching the fountains, corrupting even the heavens, which everyone on Earth today can see are now groaning in decay. And that heat was needed for the fusion of elements throughout the crust, including the heavy, dangerous, radioactive elements. So Walt Brown's model has no heat problem, but it does show CPT's problem glaringly unsolvable. Though all these years later, they are still actively working on it because they don't like the fact that in their writings they call upon miracles to remove the heat generated by their flood model. But if God supernaturally removed the heat, think about that. It seems that too much heat was removed because after the flood, the Earth headed into a centuries-long, terrible ice age. That brings us to Brian Nichol, along with the aerospace industry, who produced the video Origin of Earth's Radioactivity that you can find on today's show page at rsr.org/heat. Brian, welcome back to Real Science Radio.
It's been quite a journey so far in addressing these alleged heat problems with hydroplate theory.
Yes.
I've really enjoyed it. If you ever want to get a mechanical engineer interested in talking, then invite him on the show and talk to him about mechanics or heat transfer, and you'll probably have a fan.
Oh, that's awesome. And many of our listeners, Brian, people who I've really been surprised at how much they've enjoyed this, have said they just love it. So thank you for all that. We're down to our final 7 objections, and the first 3 come from anti-creationist Glenn Kubin. He says the massive friction from the sliding, compressing, and the thickening of the continents in the hydroplate theory when the mountains rose up in a day, that would produce tremendous heat. Of course, he's right, but we'll talk about that.
Right. Another one, too, is that Kubin says the massive lava fields and other volcanic activity occurring within the short young Earth time frame would be problematic.
Mm-hmm. And then his last criticism is one similar to those of John Baumgartner, the creationist. Glenn Kubin says that the accelerated nuclear decay, which, if it all happened, if the crust got all its nuclear decay during the short year of the global flood, he says that would produce lethal heat, not to mention radiation levels. So that's Glenn Kubin.
Right. He doesn't mention, though, how that would happen. He just assures us all that it would.
Yes. So that'll be interesting, responding to Glenn. And then that last objection, it deals with the hydroplate theory's origin of Earth's radioactivity, and that's the focus of creationist Dr. John Baumgartner, his 4 criticisms. So he describes first the extreme heat released from radioactive fission of super heavy elements. So that's his first criticism.
Yes, and then Baumgartner uses Dr. Brown's own energy estimate for the production of something called heavy hydrogen or deuterium, and multiplies that value based on a textbook answer he had read somewhere by a factor of 33, and then uses that estimate for the amount of waste heat of fission products that would be generated in the crust.
Okay.
And argues that that would vaporize Earth's crust.
Yeah, so that's a really large number, a quantity of energy he's calculating. And so there goes the crust. Then,
in the order of magnitude of like 10 to the 30th joules of energy.
Okay. And so then you take all that heat, and Dr. Baumgartner then argues that all that would be dwarfed again by a factor of 10, and that is there'd be 10 times more heat than all of that from the waste heat produced if Walt Brown were correct and super heavy elements were created during the flood by nuclear fusion. So he's building up larger and larger quantities of waste heat that's going to just vaporize everything.
That's what he assures in his review, in the flood science review, yeah. That flood science review that I mentioned is something that I believe you said you were going to be linking to, Bob.
Yes.
So
yeah,
listeners can review that in detail.
Yes.
And then a final criticism of Baumgartner is that the thermal energy that was dumped into the water beneath the granitic crust being ionized would have turned into such a hot plasma that it would, according to him, be so energetic that it would just blow the crust off the face of the Earth.
Yeah. All right. So really in all of that, we have 2 topics. We have the lava fields and the melting from the mountains rising up in a day. And then we have the heat generated by all that radioactivity and nuclear reactions. Radioactivity could be mystifying, so perhaps we could begin by demystifying it. Brian, the hydroplate theory events, they use heat not only to launch the fountains, but the production of Earth's heavy radioactive elements, that absorbs heat. So the dangerous elements like radon and uranium that were not part of the Earth's created crust but are there today, they were produced, and this is shown in laboratory tests, they could be produced by the conditions that arose during the flood.
Yeah, that's the revolutionary part of Walt's chapter on the origin of radioactivity, is to describe how these elements, these heavy elements, were generated in the first place during the flood.
So when Dr. Baumgartner says that fusion, for example, would melt the crust, well, again, one good experiment is worth 1,000 expert opinions, and this nuclear process has been replicated in the lab thousands of times. They've done this. Originally, it was all in the Ukraine at the Proton 21 laboratory, then in Germany, and the results were replicated, at least initially. They're being replicated with more work to be done here in the U.S. at John Baumgartner's own Los Alamos National Labs. It's funny that he worked at the very place where they replicated some of this Proton 21 work, and we'll link to their report on that. But Brian, the world's leading expert who says that you can fuse these heavy elements together, his name is Dr. Stanislav Adamenko, and he says that the process does not produce heat.
Right. He calls that process a cold repacking, referring to the subatomic particles, and that the process, which is the central mechanism of Walt Brown's radioactivity chapter, overall is an adiabatic process, which means that it's not producing or absorbing heat. It's basically heat neutral.
So that when there is this criticism, and it doesn't only come from the creation scientist and the leading anti-creationist, but then folks who are against creation generally, they pick up on it and they say, oh, look at all that radioactivity, it would melt the crust. But it turns out that all these experiments show that, in fact, heat is not generated. And I think this is shocking to many people. They're not aware of this. And so there's a real education that needs to occur. You and I have conferred for this episode with a few other folks, a reactor engineer at one of our nation's major nuclear power plants. We can't yet share his name, but we also talked with a PhD in nuclear physics, Dr. Josh Spencer, and with others who worked in the U.S. Navy's nuclear engineering program, including an instructor, and with Dr. Brown himself. So there's a bit of a challenge here, Brian, but could we try to give a thumbnail explanation of Walt's origin of Earth's radioactivity?
Yeah, I think we can. We should add that these results of the Proton 21 lab, which Dr. Adamenko is overseeing, he readily will provide samples of these screens where he's catching these super heavy elements, and he'll make his data available, and he'll provide his own screens that he's produced these elements in to anybody who wants them, so that they can take them and analyze them under their own microscope if they don't believe him.
Yeah, and if you have an AMS machine, an accelerator mass spectrometer, which in fact a friend of Real Science Radio is Dr. Steve Taylor at Liverpool, and he's got those devices. So I think I'm just now convincing myself I need to ask Steve if we could use one of his machines and check out some of Adamenko's specimens.
Yeah, that'd be quite a fun project.
Yeah. So the origin of Earth's radioactivity, where do you start on a radio show? I think with earthquake lightning, Brian, that's something that people could get in their minds. When there's an earthquake, it turns out that there's lightning that happens in the crust.
Yeah, and Walt explains all of this in his radioactivity chapter that's free to read online. We're all familiar with lightning as it occurs in the sky from cloud to ground, and any sort of lightning like that is the result of electrical potential energy or a voltage building up between, in the case of the sky, the clouds and the ground, and then the air between that, the air gap, our atmosphere. When you get a voltage potential that's high enough, you get a spark, and that's the electrical breakdown of the material. In the case of regular lightning, it's through the air, the breakdown of the air, and you get a spark. You get lightning.
And how about in the crust?
So in this same scenario, in the crust, because granite, our Earth's crust is made of mainly granite, the continents are made of granite, and granite has a very high percentage of a material called quartz, up to around 30%, I think. And quartz is a material that has what's called piezoelectric properties. And what piezoelectric means is piezo meaning pressure, and then, of course, electric, we know what that is. So when you apply pressure to quartz, it can generate a voltage in the same way that the clouds to the ground can build up a voltage. When you flex quartz, when you pass pressure through it, either tension or compression, the quartz will generate a voltage, and much more tremendous voltages than just the cloud to the ground.
So when there's an earthquake, we know today, because of all the security cameras at night, there are oftentimes earthquake lights where there's light above the earthquake, like lightning going up into the atmosphere.
Yes, it's been a very fun time to live in. When I know it's terrible, some of the results of earthquakes, but it has been very interesting to see the shots, especially at night when an earthquake happens and you see basically the top of lightning strikes that are happening within the ground during the earthquake. A lot of weird lightning on the ground happening.
Yes.
And a lot of security cameras pick that up. And that is confirmation of, on just a small scale, of what Walt's talking about that happened on a much grander scale when flexing that was happening in the crust was many, many times greater, and therefore the voltages and the discharges were much more powerful.
And there's a lot more evidence for what I'm calling now earthquake lightning other than just earthquake lights. There are many reports in the literature. They take granite in a laboratory and they compress it and they measure the voltages. Walt Brown has a neat little device he made in his office, and my son turned the handle and a light bulb lit up, and all it was doing was compressing a piece of quartz. So this is a very well-known phenomenon. Now, it turns out when there is lightning, that lightning in the atmosphere can squeeze together atoms to make heavier atoms. Actually, what they're doing, it's called Z-pinch. They're squeezing together nuclei of atoms and making heavier elements out of them. And in the Earth's crust, what happens in this lab in the Ukraine, the Proton 21 laboratory, and in Germany and here in the U.S., that was happening throughout the crust, where that earthquake lightning is squeezing together nuclei and producing heavy elements, including all the radioactive ones that are unstable, that God would have never created because they're dangerous and they produce birth defects. So in the perfect creation, God is not going to put uranium in the crust of the earth. That would make no sense. But we now know, because of Walt's discovery, that the piezoelectric effect during the flood in the granitic crust, that's where all these dangerous radioactive elements in the crust came from.
Yeah, they were produced during God's judgment on Earth during the flood.
Wow. And earlier you mentioned the word deuterium, that heavy hydrogen. That was produced at the same time also. That's not dangerous, but why was that produced?
So the deuterium was a result of the generation of these many heavy elements and the subsequent breaking apart of even the heavy elements, because this was during this time, in the initial stages of the flood, when the granite crust was flexing and producing the Z-pinch voltages. It was a very chaotic, random nuclear environment within the crust where you had all sorts of light rays, high energy light particles, and subatomic particles being slammed around into all sorts of different atoms. So some of the newly created heavy elements like uranium were artificially decayed more rapidly than they otherwise would have. And a lot of these subatomic particles, one of them was fast neutrons that were generated during the fissioning of these elements. One thing that Dr. Adamenko notes in his literature is that once the Z-pinch occurs, it slams a whole lot of atoms together and generates a super heavy atom, bigger than anything that's in our naturally occurring elements. And it is so unstable that it immediately fissions back apart into many, many different fragments, some of which might be uranium. Some of them might be heavier than uranium. And so this environment produced a lot of free neutrons or fast neutrons. And those fast neutrons carried with them a lot of kinetic energy as well as the fission fragments. An important thing to remember is that this process, the Z-pinch process where you create heavy elements from lighter elements, is that when you create elements that are heavier than 60 atomic mass units, or about the size of an iron atom, if you take and create elements that are heavier than that, like uranium and things, that actually absorbs energy from its surroundings when this happens. And so
it
overall,
absorbs
that's
heat.
why Adamenko reports that this process is adiabatic. In the case of hydroplate theory, though, some of that energy was driven into these fast neutrons, and these fast neutrons were absorbed, their energy, their kinetic energy was absorbed by supercritical water that was underneath the crust. And that supercritical water transferred that heat energy into kinetic energy.
So if we think back to during the weeks of the flood, you have lighter elements that are being squeezed together to form bismuth and polonium, radon, radium, thorium, uranium. So these elements are being formed, and they're being formed in very specific ratios in the crust all over the earth. But then there's also heat, like you just said. Some of this is going into forming this heavy hydrogen, and that's why some of the water in the oceans is heavy hydrogen. That's why some of the water in comets is heavy hydrogen. But
go ahead. The way that heavy hydrogen is produced is in today's, say, nuclear power plants and whatnot. This fissioning produces the fast neutrons, which are expelled into water, and water, of course, has a couple of hydrogen atoms attached to an oxygen atom. And the hydrogen picks up these fast neutrons, and so it becomes heavy hydrogen, because instead of just being a proton, now it has a proton and a neutron. So it's a hydrogen atom, but it weighs 2 atomic mass units rather than just 1.
Yeah, so it's heavy hydrogen. So a water molecule, H2O, with a heavy hydrogen atom. So there are these heavier and often radioactive elements being produced. There's the heavy hydrogen being produced, but also then there is this energy that's being added to the water below the crust, the supercritical water, and the more heat that was generated deep down in the crust, it was added to the subterranean chamber, and what that did was it continued the launching of the fountains and the debris. So it was very energetic, that supercritical water below the crust, and the more energy you added to it, it was perfectly happy to accept it, because then it was expelling it in this kinetic energy for the launching of the fountains.
Yeah, I think that's a pretty good synopsis of Walt's chapter. I think anybody who's interested in a little more detail can certainly go online to Walt's website and read the radioactivity chapter. For a little bit of a head start on even that, they can go online to YouTube and go on to even my YouTube channel, where I have a video that covers Walt's radioactivity chapter, and view that. And I think you even offer that in DVD form.
We
as well.
do. We do. It's included with our global flood and the hydroplate theory video, which people could get from us on Blu-ray or DVD. And Brian, folks have asked, well, why do you get a DVD if it's on YouTube? Many of our resources are on YouTube, but Google, YouTube, Facebook, Amazon, they have treated us very badly in the past. They've closed down our accounts. A conservative Christian creationist account on YouTube could disappear overnight, and there's virtually no recourse.
Yeah, I wonder what the half-life is of those videos.
Yes. So
probably pretty high.
Yeah, right. Great point. So if that were to happen, it would be devastating if all this work just disappeared. But we're thankful that over the years, literally thousands of copies of these have gone out. And so there's a body of knowledge that can't be just erased by old earthers or leftists at their whim. So if we could go on now specifically to Glenn Kubin's criticisms on this topic. And Brian, first of all, he argues that, well, Walt's entire radioactivity chapter has really not been demonstrated. Walt really hasn't justified his argument. And so therefore, everything Walt says in there about heat, you can't rely on it. And when I think what Glenn has said, I just reread Walt's radioactivity chapter. So for me, that's reading it 3 times in the last 10 years. It is one of the most well-sourced scientific writings in the history of scientific writing. There are over 160 footnotes in that chapter, most of them to peer-reviewed scientific sources. The vast majority of them is based on this piezoelectric effect in the crust, and that is so well demonstrated in the literature, in laboratory experiments, in electrical field monitoring to predict earthquakes, in earthquake lights. I mean, how much evidence does he want for the piezoelectric effect? It's all there. And then the thousands of experiments showing with lightning like that, you squeeze together nuclei to make heavy elements, including radioactive elements.
Yeah, and in doing that, that produces secondary radiation. It's a German term, but it's called Bremsstrahlung radiation, and that can rapidly decay elements that are newly formed.
Mm-hmm.
Bremsstrahlung is a term meaning to slow down or to speed up or to change acceleration, and that's what this causes to happen, and it'll cause an atom to release a photon, and that photon can artificially decay another nearby nucleus and cause it to prematurely decay, where otherwise in a normal environment it wouldn't decay. I think many times these critiquers forget that Walt is a mechanical engineer trained at MIT.
Yeah.
And they forget that mechanical engineering's one of its main branches is the branch of thermodynamics and heat transfer. So Walt is well-versed in these concepts, I think more so than they realize. And I think a lot of, at least from what I've seen, myself being a mechanical engineer, their own arguments are rather devoid of their own heat transfer explanations.
Mm-hmm. Yeah, when we've pointed out that Walt's PhD from MIT was from their heat transfer division of all places. Well, also, to be good at all this, you have to be good at math. And the U.S. Air Force thought that Walt Brown was very good at math. Not everybody would know this, but he's a West Point graduate. He served as an Army Ranger, now Army, but then the U.S. Air Force asked Walt to switch services so he could teach mathematics at the Air Force Academy down in Colorado Springs. And then later he achieved the rank of full colonel while teaching decision-making at the Air War College. And Brian, when you've mentioned the charts at the back of each of Walt's chapters, they're basically decision-making charts. And the fact that he taught that very discipline at the Air War College, you could see how all that experience helped with that brilliant analysis at the end of each of the hydroplate theory chapters so that the reader can now evaluate the alternative theories and weigh the evidence and make their own decision as to which theory is actually explaining the evidence.
Yeah, I've yet to see an author go to the same level of detail in critiquing others and their own theories and putting it in a context which a viewer or a reader can analyze it themselves and make their own determination.
Mm-hmm. Now, Glenn Kubin, he also says there would be lethal heat and lethal radiation. And so this is our heat series, but maybe we could talk about the radiation for a moment, because he says with all this nuclear activity going on in the crust, it would kill Noah, everything on the ark would be dead. But nuclear engineers, they use water for cooling, and about 20 feet of water would shield the workers in a nuclear power plant from the radioactivity. So that's what we had during the flood.
Yeah, I'd invite anybody who questions that or really believes this idea that the presence of radiation just means that all life would be destroyed, even if that radiation was somewhere near the surface, which, of course, hydroplate theory doesn't say that all the radiation was at the surface.
No, of course.
A very small amount was at the surface. But, you can go to Wikipedia or do a search on the internet for, how much water does it take to shield from highly radioactive materials, and about 20 to 40 feet of water just for safe measure is used. And you can see pictures online of operators right above that water, and they don't have really any protective equipment on, no face masks, no big suits.
Right. In fact, I can see their hands and their necks. So they're, right above the water that's shielding them from the radioactivity.
Right. And so after the flood, according to hydroplate theory, most of the radioactive material in the granite was buried by an average mile-thick layer of newly laid down sediments on all the continents. Yeah, and those sediments themselves were water permeated. Mm-hmm. So not nearly the terrible radioactive environment that I think the critics are imagining.
And think about it. For Kubin here, this is his argument against Walt Brown's hydroplate theory. So when I make an argument against someone, like against catastrophic plate tectonics, I really make an effort to make sure that each of my arguments are solid. And as we've seen, we've gone through now 15 of these arguments, and there's not a one of them that are solid. Not a one of them realize that as fluid expands, it cools rapidly. And so the hot water below the crust is cool by the time it reaches the surface. How could not one of the critics recognize that? And it's one of the most fundamental facts of thermodynamics.
Yeah, it's a good question for the critics. This might also explain this newly made radioactivity during the flood. We have all sorts of studies that show that the human genome is not evolving, it is devolving, and at a very high rate. And a lot of that devolution is due to the effects of being exposed to high energy particles that mess up and cause mutation in the genome DNA structure. And generations after the flood, we see an exponential decay in the life expectancy of the generations after Noah.
Yes, and just as radioactivity causes mutations, so too that decrease in lifespan could absolutely have been caused as a primary factor in all this newly formed radioactivity in the Earth's crust. You just said that word devolving. Brian, I have here in my hand a book by the world's leading anti-evolutionist. He's Dr. Michael Behe. He wrote Darwin's Black Box a few years ago. His latest book, he'll be on Real Science Radio in just a couple weeks. His latest book is titled Darwin Devolves, and it's about DNA. And I know that Michael Behe is not a Young Earth Creationist, so I don't think he realizes why mutations have become so much more significant in Earth's recent history as compared to the first couple thousand years of Earth's history. So at any rate, that's on lethal radiation, but Kubin also talks about lethal heat, and now we're really back on our topic. And he says that accelerated nuclear decay would also generate lethal levels of heat. Brown argues that fusion of heavy elements would absorb a lot of the heat, but he has not rigorously demonstrated this.
Well, Walt didn't have to rigorously demonstrate it because Adamenko has rigorously demonstrated it.
Yeah, right, exactly.
I think another thing that is left out of Cuban's argument there is that accelerated nuclear decay still is happening over time. And, of course, Cuban doesn't offer any data that someone else can review to see if his claims are justified. He just says it would create lethal heat. But as we'll see as we progress through this topic, not taking into account time is a very, very critical thing in determining whether an amount of energy is lethal or not. Hopefully this series has revealed the importance of carefully listening to even expert opinions and taking time to identify the assumptions in those opinions and in those explanations. And it's not an easy thing to do.
Right.
You and I both have experienced that just in going through this.
Yeah, and the audience too. It could take some time. So, Brian, continuing where we left off last week with the objections from creationist geophysicist John Baumgartner. Now, the audience will recall that Dr. Baumgartner's criticism focuses on the hydroplate theory's origin of Earth's radioactivity, and there Dr. Brown demonstrated that when the Earth was being stressed during the global flood, earthquake lightning in the granite crust produced the radioactive, and that means the dangerous heavy elements like thorium and uranium.
Right. And to summarize Dr. Baumgartner's heat arguments, he says that that process of the hydroplate theory would melt much of the globe, or much of the crust anyway, and also that it would pump so much energy into the subterranean chambers water that it would blow the crust right off the face of the Earth.
Yeah. So in that episode 4, we summarized Dr. Brown's origin of Earth's radioactivity, and we focused on something called cold repacking. Now, this has been confirmed by thousands of experiments in the Ukraine and some in Germany, and then coincidentally, right here in the U.S., at Dr. Baumgartner's old institution, Los Alamos National Laboratory, they published back in 2009 that they at least partially so far have replicated some of the work that was done at this Proton 21 laboratory, and they say that with funding, they stand ready to investigate further these amazing results.
Right. Cold repacking experimentally demonstrates that the fusion of atomic nuclei into elements of the periodic table from light to heavy, and that the whole process of doing this is adiabatic, and that means that it doesn't produce heat, certainly doesn't produce heat.
Wow.
And in some cases with the heavy elements, it absorbs heat.
Wow. So then Dr. Baumgartner's criticisms, which our listeners can read at rsr.org/heat, they begin with this, that you take the radioactive waste heat released from the fission of the super heavy elements that would have been created by Walt's theory, and you multiply that amount of heat by 33 to get the heat generated by kinetic energy that would be involved. So that's his first criticism.
Yeah, that's quite an assumption on Dr. Baumgartner's part.
Yeah, I think so. So why don't we address first that fact that that's an assumption, but then let's give Dr. Baumgartner the benefit of the doubt and evaluate this, assuming that he's right about this 33 times more heat.
Yeah, let's do that.
For this series, we've spoken to a nuclear reactor engineer at one of our nation's major nuclear power plants, and we also spoke with Dr. Josh Spencer, who has a PhD in nuclear physics, and with others who have worked in the U.S. Navy's nuclear engineering program, including an instructor there. And of course, we've conferred with Dr. Brown himself. So there was unanimity, Brian, from the reactor engineer, Dr. Spencer, and everyone who weighed in on this, that Dr. Baumgartner is making an unjustified assumption, saying, okay, now multiply all that heat by 33.
Yeah, Dr. Spencer wrote that multiplying the waste heat by 33 is an unsubstantiated assumption, and he used an exclamation point at the end of that sentence.
Right, exactly. And then our nuclear reactor engineer, he sent us a bit of a letter on this. Would you mind quoting him about this assumption?
Yeah, he writes, I'm attaching a picture I just took of my old senior reactor operator training manual. It's consistent with what you and John reference, but Dr. Baumgartner then says that, quote, if the kinetic energy of the fission fragments was 33 times that of these fast neutrons, unquote, what an assumption.
Mm-hmm. And there's an exclamation point again.
Again, another exclamation point. And then he goes on, he says, you can't take one particular nuclear reaction and assume all other nuclear reactions follow the same properties. We use uranium-235 to produce energy because of its unique properties. It gives tremendous amounts of energy. Who knows the particular properties of these super heavy nuclei fissions? We don't have the research.
Yeah. Then our reactor friend here wondered whether Dr. Baumgartner was aware that the Proton 21 lab, that work that Walt refers to was adiabatic. That is, that it doesn't produce heat. That's one of the keys to answering John Baumgartner. The lab director, Stanislav Adamenko, in these peer-reviewed publications, he'd been reporting for years that this process was adiabatic. And Walt's radioactivity chapter and his website as of early 2010 addressed all this. So John wrote his critique in the summer of 2011. So, Brian, perhaps you could continue with what our reactor engineer wrote.
The closest this research, although still far from knowing the particulars, is the Proton 21 work. That research states that cold repacking of these heavy nuclei produce daughter elements by an adiabatic process. Now, adiabatic is a thermodynamic term. I take it to mean that an equivalent amount of energy was absorbed in the fusing of these elements into super heavy elements, as was released in kinetic energy in the downstream fission products. The endothermic and exothermic reactions nearly balanced out.
So these are some pretty big science words, but for the audience, exothermic means a process accompanied by the release of heat, and endothermic is a process that accompanies or requires the absorption of heat. So our reactor friend is saying that this process balanced out so it didn't produce a lot of heat, as John Baumgartner is assuming. And then he continued, in light of the only laboratory research that comes close to replicating what Walt Brown has proposed, showing that this process results in little net excess kinetic energy, why would John make that incredible assumption? And so, Brian, we agree, our PhD friend, Walt Brown, everyone agrees with this, that in fact the actual experimental results shows that this would not produce a lot of heat, and also that this was a big assumption that John made that was not justified. But let's give him the benefit of the doubt. What would that much heat do if John Baumgartner was exactly right, and you take the energy that Walt references for producing the heavy hydrogen, and then go ahead and multiply that by 33 times? What would happen?
Well, I've looked at that, and we'll go over it here. John, I think, errors in that he's not considering that this amount of energy was dissipated over time. And that's really the reality of it. That's how it would have been dissipated. It's not an instantaneous release of energy. And so by not including a time factor, John's calculations are assuming that all that heat is happening in an instant.
Wow. So instantaneously, but that's contrary to the global flood event itself, right? the Bible doesn't say the flood happened in 1 second. It says it rained for 40 days and nights, and then we had months of continued flood activity. So Walt Brown's theory, which John is critiquing, specifically states that this all happens over this long period of weeks and months.
Right. In the radioactivity chapter, in copies at least as early as 2010, Walt considers the quantities of the energy similar to John Baumgartner's estimates. And Walt, though, he takes into account for that energy being dissipated over a period of time.
Yeah. So, Brian, it seems that this is not uncommon, that the critics do what John Baumgartner is doing right here, and they assume, against all reason, that all the energy appears instantly. It's all at once.
Yeah, that's kind of a common trait with a lot of these heat critiques. But for years now, in the footnotes of the radioactivity chapter, Walt actually shows two calculations using the same amount of energy, and he shows how that will give two completely different conclusions. So in one, he shows if you take that amount of energy he calculates and assume it's an instantaneous dispersion of energy, then you'll have insufferable heat and melting, and you'll conclude that, everybody dies.
Yeah.
But in the second calculation, he shows that same exact amount of energy, if you account for it occurring over a period of time, only very limited heating to the crust occurs.
So, Brian, you've created another spreadsheet for us. And again, I'd like to link to this spreadsheet, and we'll put it in our written show summary, which is coming along very nicely at rsr.org/heat. So what does your spreadsheet on this show us?
So what I show in these calculations are both Walt's energy estimates and John Baumgartner's taking of those same energy estimates times the 33 ratio. And then I show Walt's, basically it's just a copy of what Walt does in his footnote, where he shows that if you take that amount of energy evenly distributed over Earth's entire crust, and then you account for that being dissipated over a time period of 40 days, that the resulting energy per cubic centimeter, which is about the tip of your pinky, say,
all right,
that amount of energy would not be any more energetic than that of even a tiny LED light bulb.
So then if you take John's, in your spreadsheet, you have John's estimate that times 33, and you have instantaneously, it looks to me like he's right. The crust would melt.
Yes, and actually Walt also in his footnote shows the exact same thing with Walt's numbers.
Right.
Walt shows that, if you take his numbers times 0, basically as far as instantaneous dissipation of heat or even small amounts, that, you certainly would get melting. You'd have very, very high power output. And you would expect, in fact, Walt even goes on to say and says, you would melt the whole Earth if you did that.
The whole Earth.
So that's not realistic.
Right. So compare that to John Baumgartner saying that with this heat from Walt Brown's theory, you would melt the crust 100 times over. But in reality, that's only if it's instantaneous. If it's over 40 days, it's more like a child's nightlight in his bedroom and the warm glow you might get from that nightlight. It's more like that.
Yeah. If you evenly distributed it, even John's numbers at much higher values, taking basically Walt's numbers times 33, even that doesn't have the same power output that an LED light bulb would have if the heat was uniformly distributed over the crust.
Your spreadsheet has a great graphic showing this energy dissipation in time. And for something the size of a little tiny LED, which is about the right size, and a cubic centimeter of water and a cubic centimeter of granite crust. So this is, I think, going to really help anyone who's having a hard time following this discussion. Just go to rsr.org/heat and look for this spreadsheet. Now, when John Baumgartner, in this criticism, he makes an unfair ad hominem against Walt Brown, and he writes that scientific rigor is not a paramount issue for Brown. So that's not just saying that Walt made a mistake. You know, it's characterizing Walt as he couldn't care less about being careful with his math and all. Well, this shows how unwise that was for John to write that, because in his criticism here, and I'm not characterizing his entire career or him as a scientist, but in this criticism here, how much scientific rigor could possibly have been put into this critique when, as a geophysicist, he certainly understands the difference between an amount of energy instantaneously and that spread over a period of 40 days.
Yeah, you would really hope that he would have considered that. He apparently didn't, or else he left it out. But, I mean, engineers routinely address this type of a situation. And, I mean, we could even take, for example, a car. You know, if we said, well, how much energy does it take to drive a car across the country, and then start designing our car and then expect the car to handle all the energy it takes to drive it across the country instantaneously, then we'd all as engineers conclude that it's impossible to design a car because it would explode or melt.
Yeah.
So, of course, we know and realize that the heat transfer problem is more complex than that, and it occurs over time, and so therefore we can design a car that can dissipate heat accordingly, and it functions all the way across the country.
What I appreciate in how we're answering the heat criticisms is that we're not just being theoretical, and we're not doing as Dr. Baumgartner does and AIG and ICR and CMI and relying on miracles that are not implied in the Bible, but instead we're using experimentally tested and powerful engineering solutions to these heat challenges. This is all straightforward.
Yeah, and that's what I really appreciate about Walt's work here is, even as a young engineer, when I first started reading Walt's work, it was very straightforward, and it was right within the engineering discipline.
So, Brian, I think you just quoted Walt in saying that the heat would be evenly distributed throughout the crust. I remember that we criticized Danny Faulkner and others for claiming that with the atmosphere, they evenly distributed the heat through the atmosphere. But I see the big difference here is that we're talking about where the heat is being generated, and it's being generated throughout the entire granite crust, generally speaking.
Yeah, that's a good point. In my analysis, I'm careful to note up front that we are assuming even distribution simply to show that there's a radical difference in the results when you do that. Now, hydroplate theory would expect, as Walt points out also in the radioactivity chapter, that the reality of the situation is somewhere between these two extremes. It wasn't instantaneous, and it wasn't absolutely uniform for all 40 days, but it's somewhere in between.
Well, in fact, there were places where the rock did melt, right?
Yeah, in Walt's book, he points out that there are signatures of this very rapid dissipation of points of heat within the crust. Certain zircons show a fracture pattern that instead of just one split, the zircon surface is cracked in many spots, which means a great deal of heat was suddenly dissipated, but at a point. And so hydroplate theory shows that there were literally trillions upon trillions of points throughout the crust. And so the heat was more uniformly distributed, and it wasn't at all the same as the scenario like in the atmosphere and the ocean, where you have to show a heat transfer across a boundary layer. So the two are very, very different scenarios, which that's the way engineering problems work. You never get to just solve it one time. You always have to go back and say, what's the scenario in this case? What's the proper way to analyze it? And that analysis changes depending on the situation.
And we're speaking with longtime aerospace engineer, mechanical engineer Brian Nickel. Another weakness in John's criticism on this is that a lot of the energy that was being produced in the crust was being dumped into the supercritical water in the subterranean chamber just below the crust. Walt Brown, with his MIT mechanical engineering PhD in heat transfer, no less, is an expert in the physics of this, and he writes in his book, quote, "Any heat energy gained by the supercritical water simply increases the pressure, the velocity, and the number of droplets, all of which then help to increase the heat removal." It's so fascinating to me, Brian. It's almost like a feedback system, and we'll see another example of this soon with what we can call the quartz shutoff valve. The hotter it gets, the more heat that's removed by the function of the supercritical water, including all the work it does through its rapid expansion, which dramatically removes heat.
Yeah, and there's something else that Walt points out. As supercritical water gets hotter and hotter, the water molecules break into ions, which are positive and negative. And so most of that energy becomes electrical, what I'll call electrical potential energy, and it's not thermal energy.
Wow.
So that heat energy was stored essentially as electrical energy. And as Walt writes after the flood began, quote, "For weeks afterward, almost all that energy became kinetic energy." And that's because of the particular properties that supercritical water has.
So I think we could conclude this answer repeating the modern proverb that Walt quotes, "A good experiment is worth 1,000 expert opinions."
Yeah, I've certainly seen that in my career.
But then why was there accelerated decay during the flood? I mean, everybody in the creation movement recognizes that there was accelerated radioactive decay. And we have been taught that decay happens at a very predictable, regular rate. So how could it be, Brian, that you could have radioactive decay rapidly?
Well, one thing is that a lot of times whenever we're talking about radioactive decay, we're talking about very specific situations and normal circumstances. And of course, during the flood is very different. And so Walt observes that powerful electric fields during the flood, which were in the crust during the flood, would have sped up the radioactive half-lives even more than, and sometimes a billion-fold.
So wait a minute now. If a half-life is sped up more than 1 billion times faster than it normally would in an electric field, in a powerful electric field, which you had during the flood in the crust, then that means it would decay very rapidly and not over hundreds of thousands or millions or billions of years.
Well, for example, leading scientists have published through the Royal Swedish Academy of Sciences that strong electrical fields, when they're strong enough, they can strip certain atoms of their electrons, and doing this can decrease the half-life by literally more than 1 billion-fold. In one case, they reported that it dropped from a half-life of 42 billion years down to just 33 years.
Oh, my. So that was Fritz Bosch's work. He's this famous physicist, widely published. And so let me process that. If you have a powerful electric field that could dramatically accelerate radioactive decay, and that's exactly what creationists have noticed. If the Earth is young, there was something going on that created accelerated radioactive decay. What ICR and AIG and CMI, what they don't realize is that what was going on, described by the hydroplate theory, is the earthquake lightning in the granite crust, because so much of it is made of quartz, and all that tectonic activity produced all this electrical field. And so you did have not only the production, the fusion of heavy elements, but you had this tremendously unstable environment in which you would get accelerated radioactive decay.
Yeah, Walt describes that process, and I think as far as I know, I have not seen anybody show a mechanism that is as tightly linked to these two scientific processes as Walt's book.
In fact, I think there is no one who has proposed any mechanism other than God did it by a miracle. But for what reason? For what reason would God do accelerated radioactive decay during the flood supernaturally. And then many of them think that God then supernaturally removed the heat, but then that would have been too much heat removed because after the flood, the earth headed into an ice age. So,
yeah. Adding miracles to theories is a dangerous, kind of a slippery slope and it makes it really impossible then to have competing theories, because whenever a theory can just slap a miracle into a weak spot, how do you determine the weak spots that are true weak spots versus the patches that are miracles that are real miracles?
Yeah.
It's an impossible thing, and it makes it so that nobody can evaluate anything.
Mm-hmm. I'd like to take a moment, Brian, to share with the audience the wild world of the subatomic and thinking about neutrons. You know, along with protons and electrons, they make up atoms, but neutrons are incredibly unstable. Outside of a nucleus, as free neutrons, they decay rapidly, don't they?
Once they're outside of a nucleus, they decay within 15 minutes. A half-life anyway. Their decay half-life is just 15 minutes.
Yeah, and so then inside the nucleus of an atom, and apparently by the strong interaction, also called the strong force, that helps to hold the neutrons together so that the atom, in an atom, a neutron is stable apparently for many billions of years. And so this, I think, is a good example from nuclear physics showing that subatomic particles do the most amazing things. And as we've seen, the more we learn about nuclear physics, the more questions get answered by Walt Brown's hydroplate theory.
Pretty significant.
Yeah. Then there's two other examples of why the heat didn't melt the crust, and we could call them tunnels and the quartz shutoff valve. Can you talk to us about the tunnels?
Yeah, so Walt describes this, that because of supercritical water's properties and it's such a high-energy substance, it would have, and this is known, supercritical water is great at dissolving things. And so Walt proposes that before the flood, the supercritical water under the crust would have eaten both up into the crust and down into the mantle. And as it did that, it would have produced trillions of little tiny tunnels within the crust as it dissolved out certain minerals, which then blanketed the floor of the Great Deep.
So then, Brian, those trillions of tunnels in the crust, that gave the lower half of the crust this tremendous surface area, which could aid heat transfer, right? Surface area is critical for heat transfer.
Yeah, and it would have greatly aided the heat transfer of the crust. That surface area is critical to many heat transfer scenarios. So the more surface area you have, the greater the potential for transferring your heat. And also, supercritical water itself has a tremendous ability to absorb energy and change it. So when we talk about these levels of heat that Walt calculates, say for the free neutrons, those free neutrons dissipated their energy into supercritical water, but the supercritical water didn't heat up because it had an escape path. And so rather than heating up, that energy was transferred into kinetic energy, which resulted in the tremendous velocities that hydroplate theory shows were produced in the launching of particles out of Earth's sphere of influence gravitationally.
And you just made the point, but to say it again, the tunnels happen to be filled with a substance, H2O, that readily absorbs heat, and that's water, and in this case, supercritical water. Then this other factor that I mentioned, the quartz turnoff valve at about 1,000 degrees Fahrenheit. Could you explain that?
One thing that hydroplate theory points out is that while quartz is piezoelectric and will, if it's flexed, it will result in producing a charge or a voltage potential, and that's what was driving this nuclear engine essentially for the first parts of the flood. There is a stop valve to that, and there's a limit to which quartz will be piezoelectric. And at around 1,000 degrees, specifically 1,063 degrees Fahrenheit,
quartz loses its piezoelectric properties. So that kind of acted like a kind of a natural heat damper for the crust, so that if a certain portion of the crust had a lot of discharges through the quartz in it, and it heated up to above 1,000 degrees, which is still well below the melting temperature of quartz, it would stop, and it wouldn't be able to produce any more heat.
All right. So that's yet another factor that gets ignored by the critics. John Baumgartner, then he makes an even greater claim than what we've already considered. He says that you take all that waste heat that he had already estimated times 33, take all that energy that Walt estimated, then he multiplied it by 33, and he said take all that as waste heat and then times it by 10, a factor of 10, because he says the fission fragments of the super heavy elements would surely dwarf the heat he had already calculated. So he says, let's multiply it all by 10 again.
I think he's clearly not realizing that the process was adiabatic when the very heavy, super heavy elements were fused in the Z-pinch process, that when they fissioned, they released heat that had just been absorbed. So in much of that heat was not a net increase in overall heat energy.
Right. In fact, if you don't have sufficient heat, that process itself of the fusion of heavy elements would shut down. That's one of the reasons why the whole thing is adiabatic. And in fact, John Baumgartner has never retracted these claims. And in fact, we have a place where we record such retractions at rsr.org/retractions. And it's been now almost a decade. And Dr. Baumgartner surely by now has learned that this entire process is adiabatic. It doesn't produce heat. But if he does, send us an email or calls. He and I have spoken on the phone, we've met in person a number of times. It's been very cordial. If he does contact me and says, Bob, okay, I retract these heat criticisms, then we'll put it on our retraction page.
So, John, the second to last criticism of Brown was, he says, Brown does not mention even once the gigantic problem of the waste heat that is implied by the processes he hypothesizes.
So Walt Brown doesn't mention, not even once, this problem. And so the claim that Walt doesn't mention this problem or this issue, Brian, when I go back and look, I see that Walt began specifically focusing on this in early 2010. John wrote his heat criticism in the summer of 2011, and I found this on Walt Brown's website at archive.org. You could go back and see early 2010. This is all addressed. The fact that the Z-pinch, it's adiabatic, and that it does not produce excess heat. It's so clear, and so it's so clear, but let's take this also. Let's also give John the benefit of the doubt, and let's say the version of Walt Brown's chapter that he was looking at was an earlier version from a couple years earlier that didn't mention how Walt's theory could handle the heat. If that were the case, right, Walt puts out a theory, and now here's this big, huge problem. Well, a false theory, like let's think of CPT, catastrophic plate tectonics, confronted with a problem, a new problem like the heat problem, and it has no possible way to solve the problem, and it says it must have been miracles. When Walt's theory, if a theory is accurate, you confront it with a new problem that hadn't been considered, and you see how the theory answers the problem. And that happens overwhelmingly right here.
Yeah, and it answers the problem with sound engineering solutions.
Yeah, it's not making up. Walt did not make up secondary assumptions to address the heat issue, but the fundamental physics inherent to the hydroplate theory itself, that's what answers the heat problem.
Mm-hmm. So let's consider Baumgartner's final criticism where he says, well, let's consider what happens if that much energy was dumped into the water beneath the crust as Brown hypothesized. So then he goes on and says that it would be fully ionized into a plasma and that it would basically blow away the overlying crust layer.
Yeah. So that's an interesting criticism, that if Walt's right, there'd be so much energy that it would blow off the overlying crust. Well, John has a way, like he does here, of identifying the important issues, but it's not always as he intends. Brian, I'm thinking of examples from this meta-series where John said the granite crust could not produce significant electrical fields, and then all this data comes in of earthquake lights and on and on and on, that granite produces a tremendous amount of voltage when it's under pressure. But Let me give one other example. In our 6th episode in this Answers series, it was titled Kevin Lee Answers the Pacific Crust Objection from Dr. Baumgartner. And now listen to this. Dr. Baumgartner objected that if the hydroplate theory were true, a layer of granite crust should be below the Pacific. Right? And then he said, and that would be easily distinguished from mantle rock by seismic techniques. So he concluded there is an unmistakable absence of any thick layer of granitic crust in the Pacific Basin. Well, hold the presses, because remember, all scientists work for Walt Brown, right? So in this case, in 2017, the Geological Society of America, they published in their peer-reviewed journal, GSA Today, that a 5 million square kilometer swath of the Southwest Pacific Ocean is made up of continental crust. And that shocked them, because that contradicts plate tectonics, and it contradicts the creationist catastrophic plate tectonics.
Yeah, and it falls right in line with what hydroplate theory has predicted and what it would expect, is that, because the other thing about this continental piece of crust that they found near the edge of the Pacific, or out in the Pacific, but over off to the side, is that it was sunken down. And that's exactly what Walt proposed, was that the hydroplate on the Pacific side sank down and subsided.
Yeah, and this granitic crust is larger, this chunk of it is larger than the subcontinent of India, and it's a lot larger. So not only that, Kevin Lee and I, we shared a number of published discoveries of huge swaths of continental crust below the Pacific, exactly as Walt predicted. So, yes, Dr. Baumgartner does put his finger on important implications. And here, too, with this latest criticism that the subterranean chamber would have become so energetic that it could have blown the crust off the Earth. Brian, anyone who's read Walt's radioactivity chapter, they'll remember the astounding discussion and the maps of the Gulf of Mexico with its oil and mountains of salt all in the right places. And Walt argues that the subterranean chamber became so energetic that the entire Gulf of Mexico, that area, blew right off the crust. That's why we have that feature.
Yeah, while hydroplate theory doesn't agree with John that the entire crust would be blown off the surface, there's a multitude of good sound engineering arguments against that reasoning. Mm-hmm. But it does show that there are features of Earth's surface that do appear to have been blown off, and there is good reason to think that that possibly was due to the tremendous heat in spots being generated. Because remember, you can have the whole underside of the crust be very, very energetic and hot, but if it's uniformly pressurized, all it can really do is lift the crust. What you really need is a pressure differential in order to blow crust off of the Earth, and that's what Walt proposes and shows.
So you used the plural. I mentioned the Gulf of Mexico. Waltz, in the beginning, mentions a second location on the crust that he believes was blown right off. You recall
Right.
what that is?
Yeah, the Mediterranean Sea also is a proposed site for the same reasoning that we find for the Gulf of Mexico. There's tremendous layers of salt that blanket the floor of the Mediterranean Sea, and those thick salt layers are really what was blanketing the floor of the subterranean chamber. Apparently, so much energy was generated under the Mediterranean Sea's crustal area that it was literally blown off the face of Earth.
I think we could now reiterate our overall solution. The hydroplate theory does not have the problem that all the other flood models do, because all the heat does in the other theories is melt the Earth. That's what it does. Whereas the heat in the hydroplate theory does work. Heat from radioactivity was converted to kinetic energy. Actually, it was used to heat up the supercritical water, which became kinetic energy, doing work and launching the fountains. And you need an adiabatic decay, but not too much heat. The hydroplate theory needs heat. It actually needs heat to fuse the heavy elements, and heating water requires a tremendous amount of energy.
Right, and that same heat that was converted into kinetic energy, that kinetic energy certainly powered the fountains, but it also powered the removal of a great deal of hot material, hot mass from the underside of the crust and launched it out of Earth's surface.
So today, there's a lot of additional heat that remains in the crust, but it's not uniform. There is extreme variation in the temperature in different locations in the crust, and that brings us to the final criticisms regarding magma, and they come from Glenn Kubin. So, Brian, Glenn writes, and accurately, that Walt Brown's theory involves the undulating of the crust, and then the sliding of hydroplates, and crashing and sinking of these continent-sized hydroplates, and that would produce enormous amounts of friction and heat as continent-sized plates sped across the entire planet within weeks, and entire mountains were pushed up in hours. So, yes, we agree, Walt agrees, it's in his book, that a tremendous amount of heat is generated and magma. But let's focus first, Brian, on just Glenn's claim that the sliding of the hydroplates would produce this tremendous heat and melting. How about the sliding of the hydroplates?
Well, one thing about that is during the slide, I mean, they're hydroplates. They are sliding on water, and not just water like liquid water. They're sliding on supercritical water. And so supercritical water is very unique, and it's more like a gas as far as what the plate was sliding on. So if you take, for example, a air hockey table, and you don't turn the air on, but you just put some liquid water on the air hockey table and try to get your little
you hit the puck
to slide across it, what would happen?
Right, it's not going to go so well. You turn on the air hockey table so that you've reduced the friction, and you barely touch the puck, and it goes all the way across the table.
Right, so that's what the hydroplate theory proposes. The hydroplates we're sliding on was more akin to a gas, and so very, very low friction, if any.
So that perhaps even 38 times or so more slippery, so to speak, than liquid water.
If you look at a dynamic viscosity table for water and compare normal liquid water under normal conditions to water at supercritical conditions, the ratio is that the supercritical water is 38 times more slippery, I guess. So
in fact, I'd like to embed such a table in our written summary at rsr.org/heat. So that part of Glenn's criticism is overstated, but the rest of it, he's exactly right. When you have the hydroplates that are now running out of water beneath and they begin to grind to a stop because they're hitting the floor of the subterranean chamber. And with all that momentum, that inertia, they are thickening and the mountains are rising up in a day, so they're being crushed. That produces a tremendous amount of magma.
It certainly does, and that explains why we have so much magma and why that magma is so shallow and right underneath our continents and not super deep down in the mantle. And so that heat generated is, as hydroplate theory would expect, it's spotty, just depending on which part of the plate hit the surface of the mantle first and skidded across it and melted the underside of that. But it certainly wouldn't have resulted in heating that would have melted the entire crust, but it just melted the underside of the crust. And so that heat, solid rock above it, the rest of the hydroplate that didn't melt acted as an insulator to life that's happening, above. And so it's certainly not a doomsday scenario that Kubin alleges.
Right. And when you said it's spotty, the geothermal heat is extremely irregular. And if the
extremely irregular, yes. That also strengthens the young Earth position, because hydroplate theory would say that all of this happened very recently and it hasn't had time to dissipate to a uniform geothermal uniform level.
Right, exactly. Also, as this magma is being formed, the rock, the friction, the rock is melting. It's melting in the context of a global flood, and that's something Glenn overlooked. So you have melt at the surface, near the surface, deep below the surface of the Earth. The melt at the surface is melting into the floodwaters. And
anything that escaped to the surface was hitting the sediments and the floodwaters that were collected above.
Right. So water is a fabulous coolant. And so the water on the surface, whether it's magma that's spilling out onto the newly formed ocean floors or onto the continents, you've got floodwaters and surface waters, which are cooling those lava fields. And then even deep into the crust, you've got water still remaining in the subterranean chamber. And you have those trillions of tunnels filled with water that can all help dissipate heat. So when you look at the whole picture and not just a narrow part of the picture, you are better able to assess a theory. When I look at the U.S., Brian, I notice that in the western U.S., there's way more heat, geothermal heat, than in the eastern U.S. And that's because, as the hydroplate theory explains, the North American continent slid to the west and began to grind to a stop, and the mountains rose up north-south, because that's how the continent would crumble. And we find the heat pretty much from a general perspective where we would expect to find it.
Yeah, that's one of the beauties of the hydroplate theory, is that it's very predictive, and where you would expect there to be heat, look at that. There's heat, and there's a justified mechanical explanation, cause to effect reasoning throughout.
That about wraps it up. Brian, it's outside the scope of this series, but in the future, Real Science Radio plans to do a program on polonium halos. And in that show, it's almost like a bonus to the series. We can turn the tables on the critics, because even the atheist critics of Walt's theory, they all have, and so do the creationists, a serious heat problem in the crust of the Earth all over the globe with polonium halos, and the hydroplate theory answers that problem. So they have this heat problem in thousands of points in the crust, and that's going to be fun. And so we'll link to that show when we do it. It'll be at rsr.org/polonium halos.
Yeah, that'll be a good series to look forward to.
Thank you. And now, Brian, that's it. We're done.
That's great. That's great.
I need to exhale.
Me too.
So we've addressed 4 critics: the anti-creationist, Glenn Kubin and Tony Reed, and
the Young Earth Creationists, Danny Faulkner and John Baumgartner.
Right. Between the 4 of them, they had a combined 20 arguments claiming the hydroplate theory would boil the oceans, cook the atmosphere, and melt the crust.
Yeah. And then we employed about a dozen factors to evaluate those ideas and then show that they actual heat transfer scenarios of the hydroplate theory, including the known concepts that gases cool rapidly when they expand, and also the concept that you can't just take pure energy. You have to understand if that energy exploded or if that energy was directed.
Directed energy. Brian, then there was the significance of boundary conditions, which even though I'd read about it and we talked about it, it really didn't drive home for me until we recorded this series. You've got the boundary conditions, and then you've got the role, the behavior of supercritical water, which was so significant.
Yeah, and the nearly heat-neutral fusion events of heavy elements, the fusing of heavy elements actually absorbs energy, and that the Z-pinch process that Walt describes is an adiabatic process.
Wow. So I assert here on Real Science Radio, using the science in Walt Brown's book in the beginning, that we have answered the hydroplate theory heat criticisms.